Hi everyone, today you will be learning how to multiply polynomials. So be sure to write today's FLT down. Given polynomial expressions, I will be able to multiply them by applying distribution and the area model. So let's take a look at how to use distribution. So you've probably seen distribution somewhere along the way in your math classes. So let's say we had 6 times parentheses x plus 4, then we would distribute the 6 to both the x and the 4, so that becomes 6 times x plus 6 times 4. And rewriting that, that would equal 6x plus 6 times 4 is 24. So distribution with polynomials is really similar. So let's take it step by step by looking at some examples. So here I'm going to distribute the x in the first part to both the x and the 4 in the second part, and also the 3 in the first part to the x and then the 4 in the second part. So basically, I'm distributing each term from the first part to terms in the second part. So let's take a look at each distribution. For this first one, x times x, and also x times 4. So I can rewrite that as x squared plus 4x. And then I'm going to look at how I distributed the 3. So I have 3 times x and 3 times 4. So I'm going to rewrite that. So plus 3x plus 12. And if you notice here, now that we've multiplied it out, we notice two linear terms. So we can combine those. 4x plus 3x, that's 7x. And then everything else I'm just going to bring down. So x squared plus 7x plus 12. So I've multiplied the polynomials out to get x squared plus 7x plus 12. And go ahead and pause the video if you need some time to process this information. Okay, so let's look at another example. Remember, the idea is to distribute, so to pass out all the terms. Right, so here first I'm going to distribute the x to both the x and the plus 2 in the second part. And don't forget that we also have to distribute the 5 to the x and the 2. So let's look at the blue arrows. We have x times x and also x times 2. So let's rewrite that as x squared plus 2x. And then let's look at, I don't know, whatever color red this is. We have 5 times x and 5 times 2. So plus 5x plus 10. And then, wow, there's like terms, so we can combine those. So 2x plus 5x is 7x. Everything else just comes down. So x squared plus 7x plus 10. Woo! So go ahead and try this next example on Edpuzzle. Be sure to take your time and show your work in your notes. All right, so we just talked about distribution. So next, let's look at how to use the area model. So way back in the day, during simpler times, when we were first learning math, if we saw something like this, we just counted out how many squares they are. Like 1, 2, 3, 4. And then we would have been like, oh my goodness, there's 18 squares. But then eventually we learned an even simpler way. So think of it as like finding the area. we just learned to do 3 times 6 equals 18 squares. So very similar idea here. What I'm going to do is to use the same example from earlier, but instead we're going to try using this thing called the area model. So what I'm going to do first is draw this little box. Kind of reminds you of like the Punnett squares back from bio class maybe. So I'm going to make this box. And then so first, this x plus 3, I'm going to write it up here, x plus 3. And then the x plus 4, I'm going to write on the left side like this, x plus 4. So now I've set up the box for the area model. So now what I'm going to do is start multiplying out these like mini boxes. So first we do the x times x, that's x squared. And then we got this plus 3, positive 3 times x, which is going to equal 3x. And that's a positive, so positive 3x. And then we come down here. So the x times the positive 4 is positive 4x. And then this last mini box, positive 3 times positive 4 is positive 12. And then if you notice here, we have two linear terms, the positive 3x and the positive 4x. So if you combine that, that would be positive 7x. And everything else stays the same. So we have x squared plus that 7x plus 12. So x squared plus 7x plus 12. Surprise, surprise, this is the same answer that we got earlier. So using these two different methods is actually like a really good way for you to check your work. Like you can try doing it with distribution first, and if you need to check your work, you can try the box method, or vice versa. But for now, try practicing with both. So let's practice one more time, the area model. So again, this is the same example as example 2 from earlier. So I'm going to start by drawing this box again. We're going to split it into 4 separate mini boxes. I'm going to write this x plus 5 on the top part, and then on the left side, I'm going to write out this x plus 2. So let's start multiplying out each mini box. So first, x times x is x squared. And then what is positive 5 times x going to be? So that is positive 5x. Moving on to the bottom row, x times positive 2. This is positive 2x. And then this 5 times 2. So positive 5 times positive 2 equals positive 10. And then again, right here I notice like terms, so I can combine them. That's going to be a 7x, positive 7x. So again, x squared plus 7x plus 10. Again, it should be the same as earlier. So on Edpuzzle, go ahead and try this example using the area model. And now that we know how to use both distribution and the area model to multiply polynomials, let's look at a few more examples here. So right here, let's use distribution first to multiply these polynomials. So remember, I want to multiply each term in the first part to the terms in the second part. So I'm going to distribute that 5y to the 2y and negative 3. And then right here, the negative 1 to the 2y and negative 3. Right, so let's go through each one. 5y times 2y, and we also have the 5y times negative 3. So 5y times 2y, that can be written as 10y squared. And then that 5y times negative 3 is negative 15y. And then these blue ones, negative 1 times 2y, and negative 1 times negative 3. So negative 1 times 2y is negative 2y, and a negative times a negative is a positive, so we got that positive 3. Right, so notice here, we can combine some like terms. So we have this negative 15y and the negative 2y. So we can combine that into negative 17y. And then everything else just stays the same. So 10y squared minus 17y plus 3. So again, I encourage you guys to look back, pause the video if you need to. Make sure you have this down. And then now let's try the area model. So we have this 5y minus 1 and a 2y minus 3. So let's write that out. And then let's start multiplying out each mini box. So 5y times 2y is 10y squared. Negative 1 times 2y is negative 2y. 5y times negative 3 is negative 15y. And lastly, negative 1 times negative 3 is positive 3. And then again, here we notice some like terms, the negative 15y and the negative 2y. So if we combine those, that's going to be negative 17y. Let me write the other stuff too. So 10y squared minus 17y plus 3. So same answer with both methods. Right, so please answer this on Edpuzzle. Try using both methods. And so show your work using distribution and the area model in your notes. And also be careful about the variable we're using right here. And in this last part, let's talk a little bit about multiplying a binomial and a trinomial. So notice in this example, we have a binomial, so something with 2 terms, and also a trinomial with 3 terms. This might look a little confusing, but don't worry, it's basically the same steps, just doing a little more. So first, let's look at how multiplying by distribution would look like. So we're going to distribute this a to the a squared, 3a, and also that 5. And next we'll distribute the 3 to the a squared, 3a, and 5. So let's take it step by step. A times a squared is a cubed. A times 3a is 3a squared. And a times 5 is 5a. And then all that blue stuff. So 3 times a squared is 3a squared. 3 times 3a is 9a. And 3 times 5 is 15. So next, let's see if there are any like terms. Yes, there are. So the 3a squared and this 3a squared over here, those are both quadratics. And then the 5a and the 9a over here, these are both linear. So let's combine first the 3a squared plus 3a squared. That's going to be 6a squared. And then the 5a plus 9a, that's going to be a positive 14a. Everything else just comes down. So we have a cubed plus 6a squared plus 14a plus 15. Let me rewrite that. A cubed plus 6a squared plus 14a plus 15. So here we use distribution, but now let's try it using the area model. So I set up the box like this. Honestly, you could write it as a 2 by 3 or a 3 by 2. I just chose this way because I just have more space horizontally. Okay, so I have the a plus 3. Then I also have the a squared plus 3a plus 5. So let me just write that out into the area model. So this little box thing. And once it's set up, I can start multiplying. So a times a squared is a cubed. A times positive 3a is going to be positive 3a squared. A times 5 is positive 5a. Now to the bottom, so positive 3 times a squared is positive 3a squared. Positive 3 times positive 3a is positive 9a. And 3 times 5 is positive 15. So what's kind of cool here is that the like terms actually sort of line up as diagonals. So the 3a squared and the 3a squared, and also the 9a and the 5a. So a cubed is by itself. We combine like terms to get 6a squared. Combine like terms to get plus 14a, and that plus 15 at the end. So a cubed plus 6a squared plus 14a plus 15. Again, same answer using either method. So I actually like using the area model when doing like a binomial times a trinomial. So let's try example 2, just looking at the area model. So here we have 3c cubed minus 2c and 4c squared minus 3c plus 6. So again, I'm just setting up the area model right here. Remember, your variable is c right here, so make sure you're not writing like x. Okay, and then I'm going to start multiplying them out. So 3c cubed times 4c squared is 12c to the power of 5. Wow. Then 3c cubed times negative 3c, that's going to be a negative 9c to the power of 4. And then 3c cubed times 6 is a positive 18c cubed. My goodness. Okay, negative 2c times 4c squared is negative 8c cubed. And then the negative 2c times the negative 3c, that's going to be a positive 6c squared. And then lastly, negative 2c times positive 6 is negative 12c. So honestly, this might look super daunting right now, but don't worry because you'll get used to it as you practice more problems. Okay, so do we notice any like terms right here? I notice that we have the negative 8c cubed and the positive 18c cubed. So when combining like terms, that's going to be a 10c cubed. Right, so let's write all of this out. We have 12c to the 5th power minus 9c to the 4th power plus 10c to the 3rd power, or cubed, plus 6c squared minus 12c. So using this area model kind of helps you neatly organize what you're multiplying out into these like tiny boxes. Okay, so go ahead, try this last example on Edpuzzle where you're doing a binomial times a trinomial. Right, so great job today. Here's just a quick review. So you can multiply polynomial expressions by using distribution or by using the area model. But for now, I say use both methods, and then eventually maybe you can choose one. But for now, use both methods. It's like a great way to check your work. And the more practice, the better. And that's the end.